All right, everyone, let's get going. Today we're going to talk about environment. And the environment settings in Maxwell are, I guess, the best way that I can describe them is very difficult and non-intuitive. However, the Maxwell software developers have put out a pretty nifty little guide that is at least moderately helpful. So that is kind of going to be our primary resource for understanding the settings that are available to you should you choose to modify them. I will say this though, it's not very comprehensive, I guess, in terms of being able to explain everything and all the weird nuances about it. But it's at least a good starting point. So what we're going to wind up doing today, just so you're all aware, is we're going to go through and understand what each of the settings actually does to the best of our abilities right now, and then we're going to explore them. So similar to the way we did that sort of collage of 3 separate renders with different settings, we're going to explore those again today. Okay, and then we're going to kind of do a showcase of those probably next week in order to pick out some settings that are pretty appropriate for what we're trying to communicate. Okay. So I guess without further ado, let's just jump right into it and start explaining it. The thing that you're looking for is the Maxwell for Rhino plugin manual. You can just Google it, or I'll save it on the drive for you as well. So let me do that real quick. All right, so the Maxwell plugin manual. Basically, it explains everything about Maxwell, but it explains it at like a surface level. So, I mean, imagine just kind of getting your feet wet, and somebody says, "All right, now swim." Right? It's kind of like that. Like you've tested the water a little bit, you sort of understand it, but you're not really going to understand it unless you go through the trial and error process of trying to emulate what some of their settings are saying and realizing that there are a whole bunch of other factors that really contribute, to which there really isn't a good way to explain how they work in concert until you've really gotten an understanding of what's happening where. But I can give you some best practices for a few things. So I'm going to probably just like jump a lot of this stuff, but you'll see like it goes through everything from like your camera settings and focal length settings and everything like that. So as you flip through it, I mean, the one we're most interested in here today because it's the most difficult to understand is environment. But the rest of the stuff is here sort of at your disposal as well. So I just wanted to quickly show you, how it begins to discuss, what your basic render settings are without any materials, and how you can change the sun settings, or rather the camera settings, in order to basically filter out light or allow more light in. And then it shows you focal length settings, but we're going to focus on that later. It's a little bit more advanced stuff. That's clipping plane stuff. It does teach you a little bit about materials, but not really very much. So that's what I'm getting at. Like, materials are an incredibly complex thing, and they spend about a page and a half explaining to you materials. But really, you need like a 100-page document to teach you everything you need to teach about making custom materials. So that's like the reality of it, is that's all you get, and then it moves on. So let's jump down. It's on page 38.
What's the name of this file or document?
Maxwell for Rhino plugin. Plugin manual, and I saved it in the resource folder that I just made for the class. Right here under resources. Okay. Okay. 33. Here we go. Environment settings. So I'm not going to probably explain too many things, but probably only the things that we're most likely going to engage in. And the rest, for the most part, I don't really want you to mess with, because it's going to kind of throw you off, and it's going to create complex, effects on what you're trying to achieve that you wouldn't otherwise understand. So You already are familiar with the scene manager tab for the environment, so I won't really go through that. It explains what the sky dome does from a technical perspective, but what we're mostly going to focus on is physical sky. So the physical sky is broken down into illumination properties, gas properties, and aerosol properties, right? So I don't know if our current version still breaks it down that way. Let me double check that. Oops. Yeah, it doesn't really. So ours doesn't really break it down that way anymore. This might be an old version, but it's still the same kind of engine, I suppose. But so sun temperature, power, and planet reflectance, I don't even think we have planet reflectance anymore. No, we don't. Oh no, we have it down here. But basically those are going to be how intense the light is and how much light is kind of filling up the space. So it's very similar to when you're setting up your lights. It's very similar to the wattage and the efficacy, right? So think of it that way. The gas parameters are essentially like how the sky is being filled up with other, I guess you could say, environmental influence, right? So it could look like smog. You can make it look like it's hazy, sort of wet morning. All those things are going to be affected. Basically, that's going to fill up the environment and have an effect on what is actually shown, but you need to know that it has a relationship back to where your sun is, how intense your sun is, and how large the, for I guess relative terms is the efficacy of your sun, right? So your sun power and planet reflectance. So we're going to test a few of those, and then we're also going to test some aerosol properties. Okay, so I mentioned to you a little bit about turbidity and how that was sort of an environmental influence as well, and sort of creates like like dust in the air, or if you see like a sun ray coming down through the sky, you can see all the particulates floating around. That's sort of what that is. Wavelength is about what wavelengths of light are filling the space and what's being filtered out. So you'll see some images about that. And then reflectance and scattering is again, similar to the efficacy of the light. So how much is that light going to be able to either penetrate or be inhibited by all of these aerosol, these sort of air influences. Now, you can read into each one of these a little bit more technically, but I think the things that you're probably more interested in here are these comparisons. So that's turbidity in a nutshell, right? I mentioned that you could turn it up a little bit, and I mentioned you could turn it down a little bit. The amounts that we changed it weren't really all that significant, but if you were to, it starts off at a default of 0.04, which is pretty similar to, like, I guess, California sky. Probably closer to LA because it still has a little bit of smog in the air. But around here in Orange County, turbidity coefficient of 0 is pretty much our everyday sky, right? It's bright blue and sunny every single day. It's pretty nice. So then turbidity coefficient of 3 would be like the other day when we had the fires and all the smoke was going around, and yeah, so, which is almost every other day, I guess, nowadays. But so anyway, that's pretty intuitive, I think. But this is probably something that you're very interested in. So here's what I was referring to about your sun having an effect on other settings. Because if you look at this, the turbidity coefficient is still 0, and the turbidity coefficient of 0.1, which is smaller than the turbidity coefficient that you see up here. So what this tells you is that the position of the sun actually does have, basically, it has a curve of how much environment the sun has to filter through, right? Because if you think about the physics of where the sun is, where's that marker? I don't know that I need, you guys probably all know what I'm talking about, right? So you have your planet here, and when the sun is at like high noon, it's your closest point to the sun, right? So you're getting the most direct light because it doesn't have as much environment to filter through. But if it's dusk, the sun is on the other side of the planet, and it has an exponentially larger amount of ozone and air and turbidity, right, that is being filtered through. So that is actually calculated by the engine, And so that's what you're seeing here. Okay, so you just kind of need to know that that's going to happen. So here's wavelength, what I was referring to, like it just kind of filters out, I'm not sure if it's filtering out blue light. I think that is the case. But the filtering of blue light is what's going to give you sort of, I guess, what's it called? Is it like HDR photography? Something like that? I forget what it's called. But anyway, so, and then this is that scattering, right? So remember I was telling you about how it's very similar to the way that lights work in Maxwell? Well, this is you seeing it work, right? -7 means not very much light is being emitted, or well, even if it is the same power, not as much light is getting through the space. But you increase it a little bit, and it's getting a little bit brighter around that element. But if you increase it a lot more, then there's a lot of light getting through the space. Okay, does that make sense? Or through the environment. So that's something we can modify as well. So they don't really bother showing you examples of ozone and water. They're, in my opinion, I think a little bit more of an expert setting. So it's not really something I would want you to explore unless you really are adventurous. But let's try to stick to these here. So we're going to deal with primarily turbidity. This EV factor is actually really important. That's your, I keep forgetting what it stands for. But it's a camera setting that allows, I think, environment to, hang on. That one's an important one. I just don't want to tell you the wrong thing.
So it looks like if you lower the EV, then you get a more interesting sky?
That's subjective, but...
Because like I'm looking at these other ones, and it's like EV is 15, and the second one's 15, and then the third one looks more...
Well, so here's, here you go, exposure value. So the exposure value is essentially how much light is getting into the camera, I think. And the more light that you allow in the camera, I think the more intense the settings are going to affect the image, if that makes any sense, right? So like on a smoggier day, if you have your, what's that? Oh. But on a foggier day, if your exposure setting is, I think it's low, I might have this backwards, but I think if it's lower, you're not going to get as much light into the camera. And so, like, you might not notice the difference between, slightly smoggy and moderately smoggy, right? But if you allow a lot of light in and you allow the exposure, to set for a while, then you'll essentially notice a lot more because more light is filtering into the camera. I think that's this is the part of it that gets very technical and photography-like that I'm not the expert on. So anyway, let's move on. Page 38.
Okay, I wouldn't be able to explain it yet.
Okay. So So anyway, guys, those are the primary things that I want you to focus on, just those three things. You can, or four things rather, turbidity, the EV setting, the wavelength, and you can mess with reflectance and scattering, both reflectance and scattering. They kind of go hand in hand, so you're going to want to play with those. I'm going to show you in a little bit how I want you to set up the images and how I want you to index the settings that you're using. But before I go there, are there any questions on this? Okay, great. So now you have this resource. You should be able to explore them with confidence.